Hello, we are going to continue with this educational set tonight because I haven't quite finished the Pong game. It is coming along and I'm going to have a little demonstration of it, but I just haven't quite tidied up the code yet. And there's going to be a few more follow-up videos of that as well, so that should be exciting. But let's get on with this. So, I have in fact put... For some reason I put these wires, I think that was from last time, I left these wires on here. So here is the little, this is the receiver one. So I didn't build this one last time, but I've done it in the meanwhile while you guys weren't here. And we can actually try out, this is the photo transistor. So I'm pretty sure it is actually a photo transistor. So I thought before we get into it, we'll just see if it works or not. And it works quite straightforwardly, and we're going to cheat a little bit. We're going to use these things. Sorry this is a bit of a mess, but these are half the bits and pieces are sitting on the table. So it's a bit all over the show. But anyway, I hope we have to get the right way around. So, how did I work this out? This goes to the negative bit. Oh no, that goes there. Hopefully this works. We'll see what happens. Alright, so I've not wired this up. Okay. So this thing here actually is a photo transistor, not a photodiode. You can actually kind of see it. Well, you can't see it now, but there's a little tiny thing inside of it. It makes it a little bit different to a normal... I've done this the wrong way around, haven't I? This isn't going to work, is it? Well, it worked when I tried it before. I don't think I should do it that way. No, I think... What have I done wrong? I have probably done everything wrong. I think I should do it this way. So hold on a second. I'm going to... So this thing acts like a transistor, but uses basically a response to the light hitting the actual device to act as the base does in a transistor. So I'm going to have to use this as though it was a transistor, which we haven't done anything about yet. So you'll have to, like, hopefully one day in the future there will be a video. So this one should actually go to here. So the little symbol, you can't see it, but there's a little arrow pointing downwards towards here. And so that's just like the little arrow in a diode. And so I want the positive, so the arrow is pointing from there to there, so I want the positive, this to be the higher, more positive voltage level, and this to be the more negative voltage level. So then I'm going to, with my rather bizarre little arrangement here, attach that bit to the negative rail on here with this yellow one. It's not very good of me to use only the same color, but I'm going to. And there we go, now it works. And then it kind of does this when you do this, and when I turn the lights off it kind of goes out, so you can get it to go all the way out, and then when you turn the lights back on it comes back on. So that's quite cool. So yeah, I should be able to get it to go completely out by covering the whole thing with my fingers. But I don't seem to have much luck doing that. Which is kind of weird. Because it certainly reacts when you turn the lights off. So maybe I don't quite understand how it works. It goes that dark, but then when I turn these lights off, it just goes out. But my fingers are covering it. So... interesting response. I don't quite understand that, so hopefully we'll come back to it at a later date. But tonight we're just going to see what we're going to try and build the basic circuit without this stuff. We're going to do it the way they want you to do it, and they want you to use all these little tiny wires. And the blue ones are the shorter ones, and the other ones, the yellow ones, are the longer ones. So let's just have a look. Well, we'll just do I'm going to put those over there, and I'm going to bring this over to here, and then we're going to see bouncing wave lights. Well, we've looked at all this before. There's got to be a way to take this book out, because otherwise, hold on. Is it really glued in there? You can't see what I'm doing, but I'm trying very hard to pull it out. There we go, it's out. We did it and it fell on the floor. So the way that it works is you have to connect everything up with these wires. So this one here tells you which number to go to. It says electronic roaster. So that's kind of cool. That's making a sound. Oh, I see what this one's going to do. It's going to make a sound when there's sunlight. So that might be a bit of fun. Like, that's probably the easiest one to just do for a quick video. And I am feeling a bit low today because a few days ago I had a bike accident and I haven't really quite recovered. Bicycle accident. And I've gone and injured myself a little bit. And so my body's a bit achy and tired. The problem with doing this, I thought I wasn't going to cough, is that this is upside down, but I think it says 19 to 29 to 44 to 13. Really? Okay, we'll just see what that does. So let's just have a look. Let's just get some wires. This has to get out of the way. Grab some wires. So let's just find 19. So this is going to be 19 to 29. 19 to 29. That's going to need a yellow wire for that one. So we'll put that in there, because I don't think we want to go on a long video. Though we will have to do the actual transmitter and receiver component. Have I got, this is the receiver, alright. But as I said, I'll probably come back to that at a much later date. So then it's got to go from 19 to 44. Is that what these things mean? I guess it does. 19 to 44. Where's 44? It's in the middle of that one. So 29 goes to 40. No, we need a yellow one for that one too. Are we? Oh, they'll reach. Okay. And today is quite a bad day for New Zealand. Though I did go to a bunch of students protesting today about climate change. And personally, I don't think. Forget if you're not a big fan of what they're protesting about, that's fine. But I think it's good that high school students are getting the feel of having a say about things, having a voice. I don't think it's a big deal if they happen to have a day off. Alright, so now we're up to 44 to 31, which is a little bit off topic, but hey, got to say something positive today. And this one can go into there. And there we go. It's done. Well, that one's done. We've only got 1, 2, 3, 4, 5, 6. So not that many more to go. So 20, where's 20 gone? So this is connected it up to part of the transistor. So this is connected up to the collector of the transistor is going into the middle part of this thing here. So the oscillator it's creating is called a Hartley oscillator, I believe. So 20 goes, but I haven't quite got the schematics for it. So I think after we'll make this, where's my drink gone? Because I'm going to need it. It's right here. I have to move forward, and then I don't have to lean so much. Yes, what was I saying? Yeah, I'd like to actually, one of my things is I personally would like to be able to say that I actually really understand things like those kind of circuits. Things involving transformers and inductors. So this one's going to go to here. This seems a bit strange. Alright. That can't be right. So that, what am I doing? Why does this not work? Just go in. There we go. Okay, so the emitter of this is going in. This cannot be right. So 19, am I doing this correct? I'm going to turn this around for a second. Receiver. Okay, here are the hookups. Alright. I'm just going to read upside down, sorry. Actually, we don't have to do it upside down. You guys can read this. So, where does it say what the instructions actually mean? So, where I've done this, we've put all those things in. Battery caution, transformers, right. How to build a circuit. Right, okay, I'm going upside down. Yes, yes, yes. Well, I think that's right. Okay. I don't understand why this works. So in this case here, the emitter is going into the base of this transistor. And I wish I could draw that. We need to draw the diagram. This thing I don't like. It doesn't have the circuit diagrams to go with it. So I feel that's a little bit of a shame. And then the collector of this is meeting with the collector of this, but the collector of that is then going into what happened to this thing? Oh, wasn't that supposed to be connected? Right, 31. All right, so that makes sense. That's just all the positive rail is going into the collector of both those, the phototransistor and the normal this transistor over here, this NPN transistor. So that's kind of cool. Plus, it's going into the center tap of that thing. So this is in the whatchamacallit Hartley oscillator thing. I think the main characteristic is it has a thing called an inductor, which is just a coil of wire, which is what's going on inside of the transformer. But they just seem to be using this transformer only for this side of the whole transformer. This part of using just as a center tapped inductor, which means that the wires, as I understand it, are around and around and around, but in the middle part there's another wire coming out, and then there's more wires going round and round and round to get to this one. So there's a center wire coming off the middle, so you can get in between the two. So that is a nice little diagram. So we'll talk about that, but let's just finish this silly thing so that you can see that it works, because that will be kind of cool. Because there's no point analyzing something if it actually doesn't work. So 20 goes to 28, and then that goes to 39, which is just over here. So it's going to go into our lovely green resistor, which is a 470k resistor, which is pretty substantial, but that's the base of that. It goes there, and then we've got to do 21 to 43. So where's 21? This is 21. I'd be surprised if I can get this correct because it's upside down for me, but we can have fun. And so that one's going to go there. It's going to be a yellow wire job, isn't it? So I thought it was actually going to be a bit harder to work out which wires you should use, but I think I'm doing okay so far. It's going to look a bit messy, but wait till you see my current progress on the Pong game. It is definitely messy. So I did that one, 43, and then 43 has to go to 47. And I would think that 47 is nearby. 47 is just over there. Now that makes me nervous. That's right. Okay. And I always feel a bit dodgy when you wrap wires over the top of things. But that's going to be unavoidable here. Like, because this thing is an inductor, so it's kind of going to be inducing current in things nearby it. So if you put the wire over like that, it might make an effect. So we'll find that out when we get it going, and if it makes a sound, that will be neat. So I guess some of this is going to be common to most of these things, because part of the circuit is just to get well, that makes sense, because then it's going to go through there, and then this thing is going to be affecting the current that goes through this part. So we've got to do something with 30, which is coming up next. So 30 is going to go into 33. Where's 33? It's all the way over there. That's a long one. So it's going to go into this resistor, which I'm assuming is somehow going to be linked maybe to the LED, because this is the low resistor, the low resistance resistor, in comparison to at least the one we just did. So at least in comparison to the green one. So, oh, it's not going in the thing. You'd think it would. It's a pretty... Alright. I worked out when I put these things in for this one. I don't think that one's in properly. So that's 1K, 100K, and 470K. So I think I've been mentioning what the word K means, but if you don't know, it just means thousands. So that's 470,000 ohms, and this is 510 ohms. So where are we up to now? We've done that one. Did we do 22 to 25 to 34? We didn't do that one, did we? Alright, no we haven't. So, how is 22 going to come into this? We didn't do 23. Where does 23 come into it? It doesn't. Well, that doesn't make sense. 22 to 23, 21. Because something, no, we've got to have 23 in here somewhere. That's a 32. What am I reading here? 22. No, 22 is this one. Sorry, I thought that was 22. I don't know why. Well, that makes sense, because otherwise this capacitor wouldn't be used properly. But anyway, 22 goes to 25. 25 has to be nearby, so it's got to be a blue wire. This is quite fun, actually. So it might be a good idea just to do this one day, and then well, next time I'll write out the circuit for this, and then we'll try and work it out. Though I don't think I'll get very far. But then if I do that, then I can come back many months later on. So the last bit is 25 to 34, and see how much I've learnt, because so it's the analog stuff that's really going to take me a while to get. 22 to 25 to 34 in this whole electronics business. Being a computer scientist, I find the digital stuff relatively straightforward. And the general electronic stuff is relatively straightforward, even if I don't get the terms right. But analog stuff, or stuff with AC currents, this is going to take a while. You can't say AC currents, that's alternating current. But hey, we'll do that just today. I did the 30. Wait, where's 30? There's 30. I've done that one. So we've done this one. So we've only got 2 left. So we're going to do 26, which is... Where's 26? We're going to use this one too. Of course we're going to use this one too. So we're using both of the transistors. 26. I didn't even check where we're going to. We're going to 45. Please be nearby. Oh, it's over there. We can just make it. Alright. So that's good. We're going to have to use all 3 parts of this transformer here. That isn't actually being used as a transformer, because there's 2 pins over here we're not even touching. 26 to 45, done. And then 45 goes to 46, which I think is nearby, which is over here. Oh, it's the other part of the piezo transducer, which definitely sounds like something you'd get out of a science fiction film. And in fact, I mean, I'm sure they would have said that because, you know, they actually exist, and it sounds cool. Right, and 27. 27. Well, there had to be something here. So I think I've lost some of the wires. Actually, there's a little plastic bag which is right here, and we need a few of the parts. Have I used up all the yellow wires? Well, that's a shocker. I think some of them are, oh, they're on the other one. So 27 to 40. So where's 27? It's got to be this part. Yeah, we just went through this. So we're going to take the emitter of the second transistor, and that's going to go to number 40, which is, oh, I don't know where that is. 40. It's over here. Well, that's obvious. That's got to be the way. So otherwise this wouldn't be used. So there should be 2 wires. There should be 1 wire to each side of these things, and there are. And the last thing is 40 also goes to 32, and we've done 32 at some point, haven't we? Like, it sounds familiar. 32 is the power one, so it's over here, and we're going to need a yellow one for that. So we're going to have to take it off the other one. I hope there are enough wires. I hope I haven't lost them. And that makes sense because we haven't actually stuck anything into this one yet. So where did that one go? It goes back into 40. So this is the ground point for the whole thing. It's just this one here. The negative, right. Alright, so let's just... We probably should put these funny little things on that allow us to attach the fiber optic bits. So they kind of want you to stick this out the window. So well, hopefully this makes it a bit easier to make it blank out. So if I do that, I think that's how it goes. So now it's got a big dorky wire on it, but I don't see how the light's not going to get in anyhow from the side. But then again, I guess, you know, they're assuming that it's dark on the inside, so then that's not a problem. It's only when there's light on the outside. So there's no real point, actually, to doing this. We'll just leave it like that, and a little bit of light can get in there, and then that can turn it on. So let's get our little 9-volt battery, and I bet you it just doesn't work. But let's just have a quick double check. So there's something going into everything. That one's got 2 things. That one's got 2 things, that's got 2 things, that's got 2 things, that's got all its 3 things, that's got 3 things. There's quite a few wires going into these ones. That one looks all good, so let's find out. Well, it reacts, doesn't it? That's quite cool, actually. So when I take the fiber optic cable and I point it at the light, it goes all the way up to there, and when I point it down into the dark, when I take it out of there and I cover it up, the only problem is that's not turning off. Like, that's neat and all, but I don't want a rooster that just happens to have a very high-pitched voice in the morning and otherwise has a very annoying voice during the rest of the day. But at least we know that it oscillates in a very angry way. So what is this thing say here? Have trouble getting up in the morning when your window shades are closed? Fiber optics can to the rescue. Cool. The project something. I'm going to have to turn this up the other way. Sorry. Have a stare at this for a second, and I'll wave my hand backwards and forwards for a while. And there's a plastic bag there. The buzzer should go off because the end of the fiber should turn off. Right. Well, it has to be real dark then, doesn't it? So I'm going to. Hey, it does. So that's real wacky. Like, why does it? It must be able to see through my finger quite convincingly. It does actually work. Right, okay, it's early morning time, and, oh, hold on. And this is out the window. So are you ready for the rooster to come? Here there comes the rooster. Well, that's very rooster. I'm going to turn this off before I turn the lights back on. And back on again. And yes, so that's actually kind of cool, and it works straight off. So next time I'm going to write out the schematic for this and just see if we can kind of work out what it's supposed to do. We'll at least compare it to the Hartley oscillator that's on Wikipedia or similar places and see how similar it is and how it differs and how it might possibly work, and have a go at that. But I thought that was quite cool. We will try and build the full transmitter thing, because I want to find out what's the point. Like, there's no button to push. Like, I would expect, like, you press a little button and it makes the light come on, but it's also got the transformer here, so there's kind of like another oscillator being built, and I want to see what the point of that is. So we'll do that on another project, but hopefully we'll be onto the Pong thing. So let's just finish up by having a quick look at where Pong is at for now. So we'll put those over to the side. Where did I put it? Oh gosh. Maybe we won't, because I don't. Oh, here it is. Sorry. It's right next to me the whole time. So I'll take it off my Raspberry Pi Annual 2018. Speaking of roosters, oh no, this has come off. I don't know what that's attached to. Oh, I do know what it's attached to. So I've forgotten. Oh, this isn't going to work. I had a little button on a separate thing because I ran out of room. Alright, we're going to have to put one here because I hadn't wired these buttons up properly. So we're going to put that button there. We're going to take that thing off. Hopefully this one goes to A0, and then I need a wire that goes from the ground point, which I assume is this wire here that's dangling off. And then we have to plug it into the 9-volt battery. So as you can see, there are a lot more wires than there were last time. There's no battery plugged in. That's a relief, because I thought it was real broken then. There we go. So at the moment they're going together, but as you can see, every time I go here, it's only one player at the moment. It flashes, which means I missed. But I can't hit the thing. Oops, I missed. I'm not very good. It's kind of got to be refined a bit. It gets faster when you do it. And oh, I missed out. So it does penalize you if you press the button when the ball is not close enough to the thing. So you have to get the ball, you have to press the button when you're within 3 LEDs of the end. And at the so that was not 3 LEDs. Bounces back. So the height in the end of the day, there will be, like, this will look a lot neater and tidier, obviously, because it will be in a proper case with nicer buttons than this. But there'll be 3 modes at least. So there'll be 1 player mode, and 2 player mode, and 2 player mode with only 1 button, so there will only be 1 set of lights going backwards and forwards, and then 2 player mode with 2 sets going at at different speeds, and probably a difficulty thing. So we're going to have to try and work out, because I'm going to use 4 of the analog inputs. But I'm not going to talk about any more of this. 4 of the analog inputs for the buttons, and then the 2 remaining ones are going to be the control switches. But we'll get back to that next time. So thanks for watching, and like, share, and subscribe.